The turbine starter limiter and monitoring, or TSLM, is part of the Power 90 upgrade from Smyrna Air Center. It is a small box that will automate the start sequence for a variety of gas turbine engines. However, in this case, it is a General Electric M601-11A. What this video is going to cover are some of the little-known features that are useful for troubleshooting, trending, and general engine health. The TSLM will capture and record a variety of parameters, including some that are optional, but for now, we'll just cover the basics. The unit is located under the floor just behind the carry-through spar. To connect and download stored information, plug in the supplied serial port to the USB connector, and then plug into a laptop. Open the VR avionics software and apply power to the aircraft. This will be showing you a live feed from each of the installed sensors, and here's what a general start sequence will look like as you're watching it happen live. Now, the graphs will automatically scale as the ITT comes up, the N1 and the N2 turbines, starter and interrupter valves, etc., etc. To view uploaded start sequences or exceedance warnings, click on File and then open History File. This will let you scroll through and observe the start history and the sweet comfort of your own office. Let's take a closer look at these, shall we? Once you initiate a start request, the TSLM goes through a quick diagnostics check. If there are any problems, the start sequence is aborted and the TSLM light on the panel will blink a code indicating which fault was detected. If all is well, the starter and ignition are turned on. You can see this in action by the voltage drop as the starter draws a substantial amount of power when first getting the N1 turbine to rotate. It's a big piece of metal and it takes a bit of muscle to get it moving. As the N1 picks up speed, you can see the voltage start to stabilize while the N1 continues to climb. From here you can see we have ignition by the sudden spike in the ITT, or the inter-turbine temperature. This is tied very closely to the limiters in the interrupter valve, which controls the amount of fuel at regular intervals to allow time for the N1 to catch up while maintaining very low start temperatures. When you see a slight dip in the ITT, this is why. Now, a single hot start can destroy an engine, and that is all but eliminated with this automated setup. It's a really sweet system. Moving on. Once the engine has developed sufficient oil pressure, the propeller will come out of feather and rapidly pick up speed. The engine and starter are turned off here, and when the ITT, voltage, N1 and N2 turbines are stable, the start sequence is complete. Let's see one in action.